Hi, welcome back. In our current video, we will talk about the second principle of distributed systems. In the previous one, we talked about scalability. In this one, we will talk about reliability of distributed systems, also known as fault tolerance. To start, we will define what reliability means uh, and what are some failure modes that we could experience in our system, and then we will talk about what are the components that could fail. So we begin by defining what reliability means. Well, reliability means the ability to keep system running under error conditions. Now, there are two kinds of error conditions. The first error condition is component. So each component in our system could fail. Components can fail for numerous reasons, for a number of reasons. The second failure is system failure. System failure is when our system no longer responds to the user. The first type of failure, the component failure in a distributed system is, I don't want to use the word allowed, but it's tolerated. Tolerated. So we allow, we design system that allows components to fail, right? That we tolerate the failure. The second failure is a failure on the system which we do not tolerate. We do not tolerate system failure because if system failure, we no longer send a response back to the user, that is completely not allowed. We want to be able to design system such that a single component cannot cause a system-wide failure. So we want to design systems that tolerate component failure, right? There are three kinds of failures that could happen in our distributed systems. First one, A, is hardware failure. Hardware failure such as disk failure or RAM overload, CPU overload, etc. To prevent hardware failure, we can do some of the following. And this is not a full list. This is different configuration that we can set up to prevent hardware failure. We can do RAID configuration on disk. So if one disk fail, we have a backup to be easily swapped out, right? We can also have swappable CPU, right? On the machine, if CPU fails, right, we can have a hot swappable CPU to quickly bring the service back up. Right, we can also have dual power supply. This is in data centers. If power dies, right, we can have diesel generators. Diesel generators. Spelled diesel wrong. Diesel's EL, I think. Diesel generators. Right. If we have a data center and our request is coming in from the data center, the power goes down, the whole data center goes down, right? So we have backup power to make sure that the data center is always up. And other things could be we have, for example, maybe additional instances, right? Etc. The second kind of failure that we could run into are software failures. What categorizes as software failures? So we usually think of software failures as failures that are independent from each other. A single machine disk failing does not mean that another machine disk is going to fail. So there may be some correlations, but not completely. So we can have software bugs. We also have maybe threat contention. We could also have resource leaks. We could also have network problems. But to be fair, we can also have network problem in the hardware failure as well. But let's say we also have maybe I/O failure and memory, etc. Right. So these are software bugs, typically caused by bugs. And needs to be patched. They generally need to be patched quickly with software. To prevent software failures, we have software testing. Things like CI/CD pipeline, We have integration tests. And of course, unit testing. All of these testing exist to prevent software failure from happening on our system. The next one is human failure. What are human failures? Well, software do not operate in vacuum, typically. We always need humans to perform operations. So human perform operations. And human perform operation make mistakes. Maybe human enter the wrong input, or maybe use the wrong workflow, or maybe just ran some thing that broke the system. So how do we prevent human failure? Well, we need better training. Better training. Updated SOP. SOP stands for Software Operating Procedures. Right? We need automation. If humans have to repeatedly press the same buttons to make certain software work, why can't the software be automated? Right, that's the idea. And of course, all of these failure modes, right, can be captured through better monitoring and telemetry. So we can log, add logging, we can add metrics, we can add metrics to logs, So we have maybe when exception metrics, when we throw an exception, the exception is caught, the exception is logged and shown on the metrics, right? So maybe we have CloutWatch metrics if you use AWS, and also of course we have alerts, right? We have alerts running to make sure that if any of these uh, components experiences any failure, right, we have human operator come in to fix the components, and um, that's how we ensure our system is reliable at a high level.